Hello, so if you remember in the last video we established that gradient was just simply a measure of how far we move up compared to how far we move across. And we came up with this nice formula that gradient, which we give the letter m for some reason, is given by how far we move up, so our change in our y direction, compared to how far we move across, which is our change in x direction. Okay. So let's suppose I've got a line here, and I know 2 points that lie on this line, and I want to find how quickly this line changes. So in other words, I want to find the gradient. So let's give this point a name, let's call it A, and let's give this point a name, let's call it B. Okay, so I want to look, well, what happens if we move from A to B? So we move from A to B, so we're moving from here, and then we're moving from here up. Okay, moving from A to B. So I just need to find how far we move across and how far we move up. Well, how far do we move across? That's our change in our x direction. That's going to be the difference between 5 and 1, okay, which is 4. We move 4 units across. Right? How far do we move up? Well, that's going to be the difference between our y coordinates. That's going to be the difference between 10 and 3, which is 7. So we move 7 units up. And that's if we move from A to B. Now, you might say, or it's logical to say, that's moving from A to B. Would we get the same answer if we move from B to A? Well, let's check. Our gradient is still the same. It's still our change in our y, and it's still our change in an x. But this time, we're moving down, and we're moving left. Okay, so we're moving from B to A. So what's the difference between 1 and 5? What's the difference? Sorry, that's our x coordinates. What's the difference between 3 and 10? We're looking at our y coordinates now. Difference between 3 and 10 is -7. Okay, so this is now -7. And what's our change in our x? Well, it's going to be the difference between 1 and 5, isn't it? Which is -4. Okay, so this is over -4. Well, if you look, the minuses just cancel, and these things are exactly the same. So it doesn't matter whether we move from A to B or B to A, right? It will still give exactly the same gradient. So let's look at another example now. We've got another line with 2 points that lie on our line. We still know that gradient is our change in our y divided by change in x. So we just work out what the change in the x is and what the change in the y is. Well, let's do the change in the y first. The change in the y, we're looking at our y coordinates. So it's a difference between 20 and 2. So in this case, it is 18. What about our change in our x? Well, our change in our x is 20 minus 2 again, which is still 18. We can do a bit of cancellation. Our gradient is just 1. So we're basically saying for every unit I move across, I move the same distance up as well. So if I move 1 mile across, I move 1 mile up. If I move 2 miles across, I move 2 miles up. This is what a gradient of 1 actually means. So here we've got another line, okay? Same thing again, our gradient is our change in y divided by our change in x. So let's look at what our change in our y actually is. So our change in the y is moving from, well, we're moving from, it's going to be 5 minus 0, right? Which is, so 5 minus 0, that's a difficult one. It's 5, that's our change in our y. Okay, what about our change in our x? Well, we're moving from 0 to 6. So it's going to be 0 minus 6, okay, which is -6. So that has a gradient of -5/6. We haven't dealt with negatives yet, have we? We've always had positive gradients. So what do you think, looking at this line, what do you think this negative means? Well, it just simply means that we're going down. So instead of going up the hill, where we have a positive gradient like that, we're now going down the hill. Okay, so we're going to have a gradient like that. This is all these gradients means. If it's positive, we're going up. If it's negative, we're going down. So what can we say in general then? Well, let's suppose we have a point here which has an x coordinate and some y coordinate. Let's say we have another point here which has another x coordinate and another y coordinate. But I need to somehow distinguish between these two points. So I'm going to call this one x1, y1, and I'm going to call this point over here x2, y2. I'm just going to number them basically. Okay, so our gradient is going to be our change in our y divided by our change in our x. So what is our change in our y and what is our change in our x? Well, our change in our x is moving from, well, it's going to be y2 minus y1. That's how far we move up and down. That's our change in our y. So it's going to be y2 minus y1. Okay, what about our change in our x? Well, it's going to be x2 minus x1. That's our change in our x. And this is actually the general formula which I wanted to get to of gradient. We just simply take the first y coordinate and take it away from the second, and then we divide it by the first x coordinate, take away our second x coordinate. But we've got to make sure that we're looking at the same set of points. So if we call this point 2 and this point 1, we've got to make sure we're looking at the 2 different points. We can't mix up the order which we take away our x components in. So let's suppose we're told 2 points, because now we don't even have to draw the graph. Now we know our little formula. Our formula was m equals change in y over change in x. Our gradient is change in y over change in x, which we've just found out is our second y coordinate, take away our first y coordinate, over our second x coordinate, take away our first x coordinate. So let's suppose we're given 2 points. Let's suppose we're given the point A, which is 5, 3. Okay, and let's suppose we're also given another point B, which is 18, 3. Okay, so what is our gradient? Well, our gradient is our change in y over change in x. So if we call this x1, y1, okay, our A, x1, y1, and our B, let's call it x2, y2. So now all we have to do is we simply take y2, which is 3, and we take it from our y1, which is 3. Okay, and then we just take our 18, which is our x2, and we take it away from our x1, which is 5. So 18 minus 5. Okay, so let's do a little simplification. What's 3 minus 3? That's 0. And what's 18 minus 5? That's 13. Okay, what's 0 divided by anything? Well, 0 times anything is 0. So 0 divided by anything must also be 0. What does a gradient of 0 mean? Well, remember the gradient just means change. So if we're changing by 0, it means we're not changing at all. So in other words, we should have just a flat line. If a flat line, we've got no gradient, we're not moving up and down. And actually, if we plot these points on a graph, okay, this would be 3. This is how far we move up. This is our y, this is our x. And then we move across 5. Okay, and this would be our point A. Okay, that's 5, 3. Right, then to find 18, well, we move 18 units across and we move 3 units up. So that is our point B. And you can clearly see that if we put those things together, we'll get a straight line.